Okay, hello and welcome to Probability Part 1. Going through some of the basics of probability and stuff that you've probably done before, but get you up to speed on this. Probability, as you know, is measured on a scale from 0 to 1, where 0 is the lowest possible value. It represents things that are impossible. And the highest possible number is 1. 1 represents things that are absolutely certain to happen. And probability needs to be thought of as a long-term thing. So, for example, if you were to flip 10 coins or a small number of coins, the randomness is going to really dominate what happens. You don't know if you're going to get 8 heads or only 2 heads or 5 heads. It really is up to a bit of luck. However, if you flip a coin 1 million times, then the proportion of heads is going to converge to the probability of heads, which is 1/2. So in the long run, things are stable, but in the short run, it's about random luck. Okay, so we're going to start with simple random experiments. And in simple experiments like flipping coins and rolling dice, then it's just about counting how many ways an event can happen and how many total possible outcomes there are. Just a quick word about the language here. Every question in probability has a setup, like you are going to flip 3 coins. That's the setup. And then the next sentence is something like, what is the probability of getting 2 heads? So 2 heads is the event. Flipping 3 coins is the setup. So the setup tells you how many possible outcomes there are. And by counting the event, you have the numerator of your fraction. That gives you the probability. Let's look at a simple example. Let's say you flip 2 coins. All right. That setup tells us that there are 4 possible outcomes. And if you don't know, you can show them in a table. Each of those 4 boxes represents one of the 4 possible outcomes. All right, so asking a question about an event, the event of getting at least 1 heads. Okay, well, how many ways can that happen? Well, 3 ways. So 3 out of 4 is the probability. All right, you just got to count. There's 3 ways to get at least 1 head, and out of 4 possible outcomes, that's how you do simple probability. Let's go on to a classic example, which is rolling 2 dice. 2 dice, if you didn't know, there are 36 possible outcomes. In this table, they use 1 die as red and 1 die as white to help you see all 36 possible combinations of the 2 dice. And 36 is a great number because it's small enough that you can easily show all 36 in a quick little picture or table like this, but large enough that you can ask some pretty interesting questions. So let's go ahead and do that. Find the probability at least one of the numbers is even. So out of the 36 possible outcomes, how many of them have at least one number is even? So take a minute, count them all up. There's a lot of them. You might have to pause the video for a second to count them all. But if you do, you'll find 27 have at least one even number. So 27 out of 36 is the probability, or 3 out of 4. You can see each of those highlighted pairs has at least one number is even. Okay, another example. Out of 36 possible outcomes, find the probability that one of the numbers is twice as big as the other. Okay, how many ways can that happen? One number is twice as big as the other. Well, there's not as many, and you can count them all without too much trouble. There are 6 ways it can happen. So the probability is 6 out of 36 or 1 out of 6. Okay. So this is the technique that you would use when you are doing simple experiments where all outcomes are equally likely, such as flipping coins, rolling dice, things like that. Okay, next big idea I want to go over is the words and or, because they are definitely important in probability. So or is definitely linked with addition, and when you think of Venn diagrams, we're thinking of unions, whereas and is linked with multiplication, and in Venn diagrams we have the idea of intersection. Okay, so let's actually draw some Venn diagrams and see what's going on. So you can see how OR leads to addition if two events are mutually exclusive. That means they couldn't possibly both happen together. That's the definition of mutually exclusive. And the Venn diagram would look like this. We have two distinct and separate circles, and so you simply add up together to get the total amount of probability. Where if the circles are not mutually exclusive, that means they intersect, and that's the classic two-circle Venn diagram, and we have to consider the middle part. If you add up the circle A plus the circle B, you've added the middle part twice, which means you must take it away to get the total amount in the two circles. Okay, this all sounds maybe a little vague so far. Let's actually use it in some concrete problems to see what's going on. Okay, we have eye color. And the probability of brown is 45%. Probability of blue is 10%. Now, this constitutes mutually exclusive because it's impossible for somebody to have brown and blue eyes. So there is no intersection here. This is a case where the events are mutually exclusive, and the numbers will simply add up. So the probability that somebody has brown or blue eyes, you just add and get 0.55, 55%. Okay, this is mutually exclusive because there's no way that somebody has brown and blue eyes. You're either one or the other. An example that is not mutually exclusive is rich and famous. So it's definitely possible that somebody is rich and famous. And these are the probabilities. Okay, if we have these probabilities, then to handle a Venn diagram, you have to start in the middle. So I've told you that there's a 3% chance of being rich and famous. So you start in the middle and work your way out from there. That means rich and only rich is 12%, famous and only famous is 2%. That way each circle adds up to the correct amount. So with that in mind, the probability of being rich or famous by the previous formula is 17%. And therefore the probability of being neither rich nor famous is 83%. You can see that as the outer area in the Venn diagram. Okay, so Venn diagrams can be quite useful when you're dealing with especially the word or and mutually or not mutually exclusive events. Okay, let's go on to the word and. Okay, and means multiplication. And particularly, we're going to focus on independent events. So independent events are things like flipping coins and rolling dice. We'll talk more about independence later and what that means specifically, but it means that if the first die I roll is a 6, it's not going to change the chance of the second die being a 6. The probabilities are the same no matter what happens in the past. Okay, so if you roll 2 dice, find the probability that none of them is a 6. Well, if none of them is a 6, that means the first roll is not a 6 and the second roll is not a 6. So that's how you incorporate the word and into the probability statement. And that means I can just multiply the two probabilities together. It's going to be 5 6 times 5 6, not a 6 times not a 6. And the answer is 25 out of 36. So the first one is not a 6 and the second one is not a 6. Let's try another one. Let's say you flip 3 coins and you want the probability of all heads. That's the event. Well, to get all heads, you have to get The first one is a heads, and the second is a heads, and the third is a heads. So all these things are going to multiply together. And it's going to be a half times a half times a half, which is 1/8. And that is the probability of getting 3 heads out of 3 coins. Okay, a slightly trickier example is, let's say you're going to roll a die over and over until the first 6 appears. So I want to find the probability of the first 6 happens on the 10th roll. Okay, so I have to ask myself, in order for that to happen, what is actually going to happen when I roll the dice, that the first 6 happens on the 10th roll? Well, that means I have to get 9 rolls where I get something other than 6, followed by the 10th roll is a 6 exactly. So that means I have to get a whole bunch of rolls, 9 of them that are not 6, and then the 10th roll is a 6. And I multiply those probabilities together. It's going to be not 6, not 6, not 6 over and over, followed by finally a 6 with a probability of 1 in 6. I have to get not 6 9 times in a row, and then the 10th roll is a 6, and that is the probability 0.0323. It's got about a 3% chance of happening. Okay, so to review, OR means addition, AND means multiplication, Venn diagrams are our friends, and in simple cases, you just have to count up how many ways the event can occur divided by the number of total possible outcomes. Okay, also check out probability part 2 before the next class.